All right, today's lesson is on uncertainty in measurement and significant figures. Every measurement is uncertain to some extent. Suppose, for example, that we wish to measure 25 milliliters of liquid. Different measuring instruments have different uses and different degrees of accuracy. Measuring a volume with a large graduated cylinder versus measuring the same volume with a smaller graduated cylinder will yield two different degrees of accuracy. The larger one may only be capable of reading to the closest milliliter, whereas the smaller one may be capable of reading to the 0.1 milliliter. Measuring the same volume with a pipette may give us a more accurate reading to the closest 0.01 milliliter. So in order for us to correctly express the accuracy of the instrument, we rely on what's called significant figures. Significant figures refers to the digits that were measured, paying special attention to the accuracy of the instrumentation. Also, when using a measurement in a calculation, we pay special attention to significant figures so we do not overstate or understate the accuracy of our answers. For example, let's talk about measuring the same mark with two different rulers and how each measurement will be expressed with correct significant figures. Obviously, the two rulers express different degrees of accuracy due to the different increments shown. A measurement expressed in correct significant figures expresses all digits known and one digit of estimation. So when we compare the two rulers, the question is, to what digit do all agree? For the top ruler, all would agree that the mark is at least 2.5 inches. And for the bottom ruler, all would agree that the mark is at least 2 inches. The next digit for both rulers is an estimate. For the top ruler, some might say that the mark reads 2.55, while someone else might say that the mark reads 2.54 inches. Neither is wrong. There is always some degree of estimation in the last digit of significant figures. The trick is to decide to what digit all agree. For the bottom ruler, some might say that the mark reads 2.5, while someone else might say that it reads 2.4. Again, the last significant digit always includes some degree of estimation. For the top ruler, we're going to say it's 2.55 inches, and for the bottom ruler, we're going to say it's 2.5 inches. The top ruler measures to 3 significant figures, and the bottom ruler measures to 2 significant figures. There is agreement on all of the digits before the last, and there is always some degree of estimation in the final digit. All right, so let's look at another measurement. This is a graduated cylinder which measures how the amount of liquid that's being held. Let's first decide to what digit do all agree. Well, the liquid is clearly between the 36 and this 37 milliliter mark. We've got 35, 36, 37, 38, 39, 40. So it's between the 36 and the 37 milliliter mark, and probably all would agree. So next, we need to estimate the final digit. Some might say 36.3, some might say 36.4, 36.5. That's fine. That's the point of a significant figure, is that there's always some degree of estimation due to the way that we read instrumentation different from each other. So remember, the last significant digit always has some degree of estimation. So we're going to call this 36.5 milliliters. 3 significant figures. Let's look at another measurement. This is a burette, an instrument that measures the amount of liquid that has been delivered through the tip at the bottom. So when the burette is full, it reads 0, and then you deliver through the bottom here, you deliver the amount of liquid and you measure it being delivered. So the increments here are listed different, backwards from the graduated cylinder that we just looked at. First of all, we need to decide to what digit do all agree. Notice that the increments shown are tenths between the measurement 20 and 21 milliliters. So we can count from the 20 milliliters. So this is 20.0, 20.1, 20.2, 20.3, 20.4, 20.5. So I would say that it hasn't quite reached 20.4 yet. So there's a little bit of blue right there. So it's 20.3 and some extra. So we can all agree that the measurement is more than 20.3 milliliters. Now we need to decide what digit is estimated. Between the 20.3 and the 20.4 increment, I would say that it's reading closer to the 20.4. So I'm going to estimate a reading of 20.38 milliliters. 4 significant figures. So now that we've looked at significant figures in measurement, let's see how this significance is expressed in numbers and calculations. In working with measurements, there are always a number of rules that govern the correct use of significant figures. Number 1, all non-zero digits are significant. 0.157 kilograms, all non-zero digits, all significant, 3 sig figs. 6.571 grams, all non-zero digits, all significant, 4 sig figs. 16.5 milliliters, all non-zero digits, all significant, 3 sig figs. Number 2, zeros between two significant figures are themselves significant. 12.03 centimeters, the 0 is sandwiched between the non-zero numbers, making it significant, so this one has 4 sig figs. 2.09 grams, again, the 0 is sandwiched between two non-zero digits, making it significant, so this one has 3 sig figs. 10.901, this 0 is sandwiched between non-zero digits, and this 0 is also sandwiched between non-zero digits, making all of these digits significant, 5 sig figs. Number 3, zeros at the beginning of a number are never significant. So, 0 at the beginning is not significant. These, however, are non-zero, so this is 2 sig figs. This 0 at the beginning is not significant because, again, it's at the beginning. This one, however, is sandwiched, so it is significant. So this number, 0.3302, has 4 sig figs. 0.0014, all of these are at the beginning. None of them are sandwiched, so none of these are significant. This number has 2 sig figs. All right, number 4. Zeros at the end of a number are significant if a decimal point is written in the number. So 250 gallons. There's a 0 at the end of the number, no decimal point, so it is not significant. This value has 2 sig figs. What about 25.0? Well, another 0 at the end of the number, however, there is a decimal, which makes it significant. So this one has 3 sig figs. So let's practice. All right, how many significant figures are in each of the following. Number 1, 123.4, all non-zero, 4 sig figs. Number 2, 9.04. There's a 0, but it's sandwiched between two non-zero numbers, so they're all significant, 3 sig figs. What about number 3, 0.0033? These zeros, are they significant? There's a decimal, but they're in the beginning, so they are not significant. So number 3 only has 2 sig figs. Number 4, 25090. Okay, now this one's easy because it's sandwiched, so we know that this 0 is significant. What about this guy right here? It is not significant because it's at the end and there's no decimal. So the 2, the 5, the 0, and the 9 are significant. This one is not. This one has 4 sig figs. Number 5, 34.0. Is the 0 significant in this one? It's at the end, yes, and there's a decimal. So yes, it's significant. There are 3 sig figs in this one. All right, so moving on. When addition or subtraction is performed, answers are rounded to the least significant decimal places. So what we're going to look at right now are the rules in using significant figures in mathematical calculations. Okay? So the rules for addition and subtraction are different than the rules for multiplication and division, so you have to keep them straight. So in addition and subtraction, what we're looking for is the least significant decimal place. So here, 16.5 centimeters plus 8 centimeters plus 4.37 centimeters. For addition and subtraction, we're looking for the least significant decimal place. In 16.5, we have 1 decimal place. In 8, we have 0 decimal places. And in 4.37, we have 2 decimal places. So the 8 with 0 decimal places is the one with the least amount significant decimal places. So it's going to determine how many decimal places our answer will have. We have 0 decimal places here. Our answer should have 0 decimal places. Well, when we do the math, we get 28.87 centimeters, and we need to round this to 0 decimal places. So we're going to get 29 centimeters because this guy had 0 decimal places. All right, let's look at another example. Again, a subtraction problem. So we're looking at the least significant decimal places. This one has 3 decimal places. This one has 2 decimal places. And this one has 1 decimal place. So our answer is going to be limited to the one that has the least number of decimal places. It's going to have 1 decimal place. So when we do the math, we get 1.651. We need to round this to 1 decimal place. We're going to get 1.7 grams for that one. Okay? Let's look at multiplication and division. When multiplication or division is performed, answers are rounded to the number of digits that correspond to the least number of significant figures in any of the numbers used in the calculation. So this is different. We're not concerned about decimal places. We're concerned about number of significant digits. Let's look at some examples here. 2.6 times 3.78. First of all, 2 sig figs in 2.6, 3 sig figs in 3.78, not decimal place, but significant figures. Our answer will be limited to the one with the fewest number of sig figs, so our answer should only have 2 sig figs. When we plug this into our calculator, we get 9.828 centimeters cubed. This has to be rounded to an answer with 2 sig figs, so our answer is 9.8 centimeters squared. 40.0 grams divided by 0.33 milliliters. All right, this guy right here, 40.0, has 3 sig figs. 0.33 has 2 sig figs. So when we do our math, our answer can only have 2 sig figs in our answer. Plug and chug in the calculator. 121.21 grams per milliliter. We need to round this to something that has 2 sig figs. So we're going to round it to 120 grams per milliliter. Remember, this 0 is not significant because there's no decimal place. All right? Let's look at this very quickly. Express the following in correct sig figs. Let's do some practicing. 2.36 plus 3380.355 plus 1.1 grams. It's an addition problem. We are looking for something that has the fewest number of decimal places. I've got 2 decimal places, 3 decimal places, and 1 decimal place. So my answer is going to have 1 decimal place. When I do the math, I get this. And I'm going to have to round that to something with 1 decimal place. 3383.8 grams. Number 2 is a subtraction problem. In this problem, I also am looking for number of decimal places. I've got 2 decimal places here. I've got 4 decimal places here. When I plug this into my calculator, I get 1.8000. All right, my answer should be limited to 2 decimal places because of the lowest significance here. So the answer is going to be 1.80 milliliters. In number 3, this is a multiplication problem, so I'm looking at fewest number of significant figures. I've got 3 sig figs, I've got 2 sig figs, and I've got 4 sig figs. So when I multiply this together, I get 31.5. Well, my answer should be limited to 2 sig figs, so I'm going to have to round this to 2 sig figs, and I get 32 millimeters cubed. Don't forget your units, very important. And my last one is a division problem. So again, I'm looking at fewest number of significant figures. I've got 2 sig figs here. I've got 1 sig fig here. So my answer is going to be limited to 1 sig fig. Let's do the math. I get 2.5. Again, we're going to have to limit this number to 1 sig fig. My answer is 3 meters per second. This concludes our lesson on uncertainty in measurement and significant figures, and I hope that you have found it helpful.